kind of whet your appetite, we'll list a few questions here, and these are some of the things that I could really relate to, and I think you may be able to also. One of the first questions, how can we ensure that our recently made products are ready for sale? When I was working in the emulsion manufacturing area, we made batches of product emulsion that were quite expensive, on the order of $20,000 a batch, and we might do 6 or 7 batches a day. And I would come into work in the morning and uncertain really if they're ready to go to the next step where they would actually be coated onto film or paper to make product. And before we had our data organized in a great way, it was really hard to tell, did we make good product or not? Or were there alarms or what happened? So it was critical to be able to determine succinctly, quickly, are the products good? Are they ready to sell? Or do we need to do some work before they go downstream? Another question that was really important was, can we make the same product at all the different sites? When I was working with Kodak, we made the emulsion in most of the continents around the world: Australia, France, England, Mexico, Brazil, and a couple different places in the United States. And one of the problems that the company saw was that a person could take a particular picture, and let's say that it had a bright yellow beam in the background. And depending on which site they were able to get those pictures developed, and if you took the prints and displayed them side by side, one of the prints may look a little more yellow, the next one might look tan, and the next one is a little more orange. So they found that ultimately the same process wasn't being followed all around the different world, even though that was the goal. So there was a big emphasis to put together a process to determine ways to make sure that we're manufacturing the same product, following the same process around the world. And again, the motto I think that Kodak created, which I thought was really good, was you use a perfect process to make perfect product. So if it was a repeatable, same perfect process every time, you'd be making the same product every time. Another question is, why isn't this product scaling up from a lab to a pilot scale? And I would think a lot of you might be able to relate to this. You may be making something on a smaller lab scale, and you want to make sure when you're going to the full-scale production that you're going to make the same product. And we'll talk about the details later on, but basically, as long as you know the key steps of your processes, and you're showing that you're doing things in a repeatable manner, you should be able to scale up and make good product. Here's another question. How can we move away from scheduled maintenance and fix only when necessary, but before a machine breaks or bad product is made? An example could be a valve that's on a critical process. And this valve would have normal operation at a certain position where maybe it's smoothly operating from close to open over the creation of the batch. But over time, you might see that the valve position might chatter over time, or it might be operating in a different position than it normally is. So if you can look at that information and react to it, then you can actually respond and do maintenance in a planned manner or planned time, rather than waiting for it to stick or seize, and you'd have to shut down production in order to fix it. So you can save a lot of money by just reacting to the data rather than waiting for something to totally fail. Another one here is, how do we make improvements without spending a lot of money? It's always nice to put in shiny new machines with all the latest technology, but as we all know, that's quite expensive. And if you can have a tool that looks at your data to tell you how to run smarter, that's really what we want. Here's another big one too. I was trying to pick a display that shows this effectively, but the idea is this chart is showing a lot of different parameters operating in a noisy manner. So how do I know what's happening here? It's hard to really distinguish. Is this good? Is this bad? From the set on the left to the set on the right, what's really different? And I can spend quite a bit of time evaluating this to try to figure it out, but it'd be nice if I could have a way to just have statistics or a program analyze that for me and tell me the result, be much simpler than looking at all this noisy information. So the answer, or an answer, is looking, intelligent process monitoring, analytics. It is a solution. This package is a way to look at the data to help you evaluate things efficiently, quickly, and effectively.